Okay, so we will come back to the topic of the whole negative area thing. Um, but first, we're going to talk about finding area using geometry. Okay. Now,
A star is a basic geometric shape.
Yes.
well, not really, but
It's that's about triangles and it's
okay.
Have you
First of all, what does a definite integral represent? Area under the curve, right? If I say evaluate the integral from -2 to 1 of 2x, that means we're finding area between the curve and the x-axis, correct? Okay, so instead of having to do approximate with rectangles, we can find exact area another way by just calculating the area with geometric shapes. Okay, so if we have triangles, rectangles, circles, we can calculate the area by using simple geometric formulas. Okay. So what we're going to do today is we're going to draw a curve and sketch in the interval we're talking about and use geometry to find our area. Okay? Do you have a question?
No.
Okay. So here we go. I want to find the area represented by this integral. Okay? The integral from positive 1 to 4 of 2 dx. All right? So what does this mean? This integral right here means find the area under the curve y equals 2 from 1 to 4. Okay. So we can sketch our line y equals 2. Right? Well, here's from 1 to 4, and we have what kind of a shape?
rectangle.
A rectangle. What's the area of that rectangle?
6.
What's so funny?
I think it's 8.
0 to 4 would be 8, right? Yeah, 0 to 4 would be 8. Okay. All right. Let's talk about this integral. Integral from -1 to 2 of x plus 2 dx. X plus 2 is a line with slope.
Yes.
Slope of yes.
Slope 1. Y-intercept of
Yes. Also yes.
I thought you were asking, does it have slope? I thought you were like saying, like, does it have slope? Like, yeah, it has slope. I'm gonna go listen to these notes. How irritating does Aaron sound?
Here's our line y equals x plus 2. And I want the area between the line and the x-axis from -1 to 2. So this blue shaded area is what we need to find. It is a trapezoid.
Yeah.
Is that how you want to find it?
Yes.
Raina's saying
It's easy.
no.
Some of these triangles, it's just triangles. It's something different.
Okay, so you can use a trapezoid because these are your bases, right?
Is it so?
Or you could do
like,
what else?
the line is like perfect slope for like a hypotenuse. So we should use like rectangles
As
and
if it would be
triangles.
not perfect for everybody.
Like if it was a curved line, it wouldn't be a great side rod.
Okay, you can do a trapezoid. Let's talk about how we would do it with a trapezoid. If we were to do it with a trapezoid, then our area would be what? 1/2. What would be the height of our trapezoid? 3 times the sum of our bases. This base
1,
plus this base.
4.
Okay. So our area would be 7/2. 7.5. Why are you saying 7.5? Okay.
7.5.
Or 15 halves, right?
Or 30 volts.
No. Okay? Or what Raina suggested, let's do this, right? Oh, what were you going to do?
I was gonna do, like, if you take the, like, the big triangle from -2 to 2, and then just get rid of, like, minus the little triangle.
Oh, that is interesting. Okay. So what Raina was going to do is take this triangle, the right triangle that has a base of 4 and a height of 4, right? So 1/2 base times height, and subtract out this wide area, 1/2 base times height, to get 15 halves. What I was going to put up here is that we could split this up to a rectangle and a right triangle, right? So we have 1/2 base times height of our triangle plus base times height of our rectangle. What's the beauty of this?
It's all the same.
Okay? Whatever you see, okay, whether you see a trapezoid, you see a triangle with a missing triangle, you see a triangle plus a rectangle, it doesn't matter, just find the area. Okay? So our integral from -1 to 2 is 15 halves. Okay? I'm going to tell you, eventually we are going to learn, like tomorrow, how to do this using the antiderivatives that we've practiced. Sometimes the geometry is going to be faster though. Okay, especially like this example. That was super quick.
I don't know.
Okay. All right, let's talk about this guy.
See, like that's not a good line to be a hypotenuse.
That's not a line. It's not a triangle.
We have a quarter circle. Okay. The integral from 0 to 1 of the square root of 1 minus x squared. Okay, let's kind of recall how to draw a circle with functions. The square root of 1 minus x squared would be the top hemisphere. Negative radical 1 minus x squared would be the bottom portion of the circle. Okay? Regardless, from 0 to 1, how do we find the area under the curve? 1/4 pi r squared. Okay? If I had the equation, the square root of 4 minus x squared, what would our radius be? 2.
Right here.
Alright. Good reminder. Okay. We're going to talk about our negative area now. Okay? When do we have negative area? We have negative area when we are underneath the x-axis. The area between the x-axis and above, okay, so the area from your curve to the x-axis, if it is above, is positive. The area between your curve and the axis, if it's below, is negative, because we have negative rectangle height. Okay, I know height you don't like to think of as negative, but in calculus we need to think of that height as negative.
So was it added to
Basically. Okay? So let's go back to this over here, our geometry way. Alright, I have two triangles right here, correct? What is the area of this triangle right here? It would be 1/2 times 4 times 2, right? Okay, so I have area of 4. Okay, but since it's below the x-axis, it has area of -4. What's the area of this triangle right here? Okay, it has area 1. When we add these two together, we have area -2.
So even though it's a negative x value for the width, still use a positive x value?
Yes. The only thing that has negative is the height. Because if you imagine we're still going left to right.
What about when you flip, so say the interval's from 0 to 1, what about when it's from 1 to 0, isn't that negative?
Okay, so if you have, so if I asked for the integral from -2 to 0 of this function is -4. If I asked for the integral of 0 to -2, it would be +4. Yeah, why? But we're doing it backwards. Okay, so now we're going right to left.
It's right to left, you're going like negative on the axis, so then it's negative on the negative.
It's like if it's a tall graph 180, then you go right.
Okay. Good conversations here, good conversations. Okay, so this will be easy now. Here I have a picture where this has area 5, this has area 4, this has area 3. But what's true about this area 4 right here?
It's negative.
It's negative. So the integral from a to d of our function we find by taking 5 plus
3.
plus,
-4.
which is
4.
okay. This is a picture that is similar to what you will see again. Okay.
I think you've seen it.
I definitely see that before.
Okay. So you've seen it. You may see something like it again. What I want to find is the integral from -7 to 5 of this function. Okay? So we're going to have to combine both of the topics we're talking about. We're going to have to use geometry because we don't even know what the equations are. And we have some below and some above the x-axis, so we're going to have to use our positive negative area concept. So first of all, I would break up the integral.
Break up like -7 to -2 for 1.
Uh-huh.
And that's -2, 2, and then
So from -7 to -2, you want to find this area first. Is that what you're telling me?
Yeah.
Okay. 1/2 base times height, right? What's the
7 halves.
huh?
7 halves.
Okay.
Where is it?
It's 1, 2, 3, 4, 5
Sorry.
times 1 divided by 2, right?
Yeah, it was 2.5.
But since it's below, it's negative, right? Okay. Then we're going to add this area. What do we have? We have a semicircle with radius.
2.
So 1/2 pi r squared.
2.
2 pi.
Then we have a triangle what is our base?
2.5.
Okay, so our base is 5 halves times our height of, okay. And then we have one little bitty triangle here. Okay, so we're going to have to subtract 1/2 base, height of, alright, so what do we have? We have negative 5 halves plus 2 pi plus 15 fourths minus 1/4. 15 fourths minus 1/4 is, which reduces to 7 halves minus 5 halves. This is nice, right? And yay for drawing pictures if we need them.
Oh my God.
Jared, if you haven't said anything, Jared's not the next slide.
Okay, we have the integral from -4 to 4 of 4 minus the absolute value of x. Okay, we know what that graph looks like. Absolutely. All right, so first of all, an absolute value looks like a V. It's negative, so it's
Down.
upside down, and that 4 means
It's up and 4 on the y-axis.
so it's a V pointing down. Where is it intercepting the x-axis?
At the 4.
Okay, I'll give you a minute to think of A, B, C, or D.
Hold on. Yeah.
Those are your answer options. Okay, everyone watching me?
Yes.
A.
Hey, you look like the grass.
A, B, C, D, E. Alright, show me what answer you think is correct.
The people in the PowerPoint are gonna be so confused.
What is going on?
I think I see
We're doing motions, by the way.
these.
Our hands look like these, guys.
Okay, we have a triangle with a base of 8, a height of 4. 1/2 base times height is 16. Okay, drawing pictures is absolutely essential.
Yeah, homework.
Homie, you had fun. I'm proud of you.
I was pretty proud of myself. Like, I wasn't even like a